Okay, so this is section 3.1. We're starting chapter 3 here, parallel lines and transversals. And so if you didn't hear me say just a minute ago, there's a lot of vocab in this chapter. It's very vocab rich. So the math calculations are pretty simple, to be honest, but the vocab is going to help. If you don't know the vocab, you're not going to know which calculations to do. And so let's start talking about different types of lines. Our first type of lines we have are parallel lines, and parallel lines are lines in the same plane that don't intersect. Okay, so they don't intersect. Perpendicular lines, however, do intersect, and perpendicular lines intersect at right or 90-degree angles. So perpendicular lines intersect at right or 90-degree angles. I shouldn't be telling you anything you probably don't already know. So we have perpendicular lines that intersect at 90-degree angles, and then we have parallel lines which never intersect at all. Okay, so those are the types of lines we'll be talking about today. Now for the types of angles. Now, if you did yesterday's e-learning and you looked through my my angle vocab review, you already know the definitions of these. Vertical angles are opposite angles formed from intersecting lines. So in these two, the vertical angles aren't just angles that are literally vertical from each other. They're angles that are opposite from each other. So not only are the two red angles in this intersecting set of lines vertical, but also the two blue angles are vertical as well. And so the special relationship between vertical angles is that vertical angles are congruent. I can make a G. My stylus is not working very well, using my one from home, and I'm not very happy with it. Vertical angles are congruent. So if I told you two angles are vertical, that I'm telling you they're the exact same size, which helps us, especially when we're doing problems like yesterday, where we have equations where x plus 4 is going to be equal to 36, and we have to solve. All right, so vertical angles are congruent. Complementary angles are two angles whose sum is 90 degrees. Two angles whose sum is 90 degrees. So what that means is that these two angles would form a right angle. They do not have to be touching. They do not have to be adjacent. Adjacent means angles that share a common side and vertex. These angles right here are adjacent because they share a common side and a common vertex. Complementary angles aren't required to be adjacent, which means they don't have to be touching. But if one of them was 30 degrees and I've got another angle somewhere else that's 60 degrees, I know that they would be complementary. They would both add up to 90 degrees. Complementary angles are two angles that add to 90. So if I gave you three angles and said 30, 30, 30, they're not complementary. Supplementary angles are, again, two angles whose sum is 180 degrees. And so a 180-degree angle is a straight line. And so these two angles, because they form a straight line, would be supplementary because they're going to add to 180 degrees. However, again, they don't have to be adjacent. They don't have to share a common side and a common vertex. They could be completely separated and still add up to be 180, and we would say they're still supplementary. So here's a question for you guys. If two complementary angles are also said to be congruent angles, how big would they be? What would their angle measure be? If I told you two angles were complementary and they're also congruent, what would that tell you about the size of those angles? Xander?
They'd equal 180.
Complementary means they equal 90. Add up to equal 90. So if I told you that two angles added up to 90, Xander, and they were also the same size, or the same measure is actually what congruent means, how big would they be?
180.
No, not 180. You're thinking both angles are 90. I'm telling you they have to add to.
Oh, 90. Okay.
So what angle plus itself would equal 90?
45.
There you go. Yep. So they would both be
Okay.
45 degrees. Yep. Now, Jimmy, I'm going to ask you this one because I know had your hand raised. Jimmy, if two angles are supplementary and congruent, how big would they be?
90 degrees.
That's right, 90 degrees. Yeah, because supplementary, this is where Xander was kind of thinking. Supplementary means they add up to 180 degrees. Congruent, again, means they're the same size. So if two angles are equal to each other and also add up to 180, 180 divided by 2 is what you would do there, and that's going to be 90. Okay, just so we're clear though, complementary angles and supplementary angles are rarely equal to each other. You could be complementary if you were 1 degree and 89 degrees. So they don't have to be equal. All right, let's get into, so that was basically some review. And so this is our part of the lesson 3.1. A transversal is a line that intersects two or more other lines. A line that intersects or crosses. That's what that trans means. It means you're crossing something. We just talked about translations and that you were crossing over around the X and Y coordinate plane, right? You were crossing over to a different part, or maybe you're just moving over one, doesn't really matter. But when we're talking about a transversal, it's crossing two or more other lines. So the example they have here is of a railroad track, which a railroad track would have two parallel lines. Usually when we talk about transversals, we think about them crossing a set of parallel lines. And then the tree here, the tree is crossing the railroad track, and that tree would be the transversal because it's crossing the parallel lines. The two railroad tracks aren't crossing, they're only crossing the transversal. So they're not transversals because they're only crossing one line. The transversal is crossing two lines, or it could be 3 lines if there was more than one railroad track there. So a transversal is a line that crosses or intersects two or more other lines. When a transversal crosses two parallel lines, we see several angle relationships that will happen, okay? And so I'm going to list them for you. So again, I've got two parallel lines. Crossed by a transversal. So think that's actually 8 different angles that are made. 1, 2, 3, 4, 5, 6, 7, and 8. I should have spaced this out a little bit more. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 different angles. So the first thing they could be is they could be supplementary angles. And we just said that means they would add to 180 degrees. So for example, if I gave you this angle and this angle, I know that they're not the same size, but because they sit on that straight line, that slanted line, they're going to add up to 180 degrees. Therefore, they're supplementary. So supplementary angles exist. We also have another one that's corresponding angles. Oh, hold on a second. Let's do vertical first. Vertical angles, because we already know what that word means. And so that means this one here and this one here would be vertical from each other, and they're the same size. And this angle here and this angle here would be vertical from each other, and they're the same size. So supplementary angles don't have to be congruent. That's why you don't see my congruent symbol pointing up to number 1. But vertical angles do have to be congruent. There's 3 other types of angles that we're going to see though here. And so they're also going to give us congruent angle relationships. The first one that we're going to see here is corresponding. The next one we're going to see is alternate interior. And then the last one we're going to talk about is alternate exterior. Told you there's a lot of vocab in this section. This whole chapter, a lot of vocab. The math calculations aren't hard, just a lot of vocab. We have to understand what we're looking at and what kind of angle relationships we have. This chapter 3 that we're in is all about angle relationships. Okay, so supplementary angles don't have to be congruent. I mean, Jimmy just gave us an example of they could be if they were both 90 degrees. These angles here aren't perpendicular, so they're not 90 degrees. Vertical angles, corresponding angles, alternate interior and alternate exterior angles are all congruent though. So let's look about, and we know what vertical means. Let's look at our new 3. Corresponding angles, and we know the word corresponding, we've used that a couple times now. We talked about, when we talked about congruent shapes and similar shapes in our last chapter. We said that if the corresponding angles are equal and the corresponding sides are proportional, then you have 2 similar shapes. So that word corresponding is not new to us. Corresponding angles are the same angle, but on a different line. And so if you look, they've kind of color coordinated this for you. The red angles here, top right angle on both of them, they're corresponding. The blue angles, corresponding. The green angles are corresponding to each other. The purple angles are corresponding. So corresponding means that's the same angle just on the other line. Alternate interior. Alternate interior angles are also congruent. So alternate means they're on different sides of the transversal. Think of alternating back and forth, back and forth, back and forth. And then interior means inside the parallel lines. So here's my parallel lines. So they're inside the parallel lines, and then alternate means on one side and the other side. So these 2 red angles are alternate interior, and the 2 blue angles are alternate interior. And so they're also congruent. They even look like they're the same size. Looks like the exact same angle, just kind of rotated. And then alternate exterior is exactly what you'd expect. It's the same thing, alternate sides of the transversal, but this time they're outside exterior of the parallel lines. And so again, the 2 red angles are congruent, they're alternate exterior, and the 2 blue angles are also congruent because they're alternate exterior. So study tip. Corresponding angles lie on the same side of the transversal in corresponding positions. I think we just went over that. Alternate interior and alternate exterior angles lie on opposite sides of the transversal. That's what the word alternate is being used for. All right. So in our next example, it says use the figure to find the measures of angle 1 and angle 2. Okay, so this is angle 1. What is the measure of angle 1? And can you tell me which of these 5 relationships does it actually have with the given angle? So we know that this is a 63-degree angle up here in red. How big is angle 1? And what's its relationship? Anybody have an answer for that? Maddox?
It's 93 degrees because it's corresponding to the angle given.
I think I'm at 63 degrees, but yes.
Oh yeah, 63, my bad.
Yep, it is 63 degrees. So it's the same size because it's corresponding. That is correct. Corresponding. Struggling. It's corresponding to the given angle. Notice that Maddox didn't say it's 63 degrees because it's congruent to the other angle. Obviously, by saying it's 63 degrees, we know that it's congruent. I'm asking why it's congruent. It's congruent because it's corresponding, because they gave him one angle here and then gave him the same angle in the same location, in the corresponding location on the other side of the line. So the right side, and then they give him the right side here. Okay, so let's do the second one then. Who can tell me how big angle 2 is and what's its relationship to the 63-degree angle? Please, not everybody at once. I can only hear so much. Xander.
It would be 117 degrees.
Good job. And is it congruent to the 63-degree angle? Is it the same size?
No.
No,
No.
definitely not. So that eliminates 4 of the 5 options. So what's the only angle relationship that we have, Xander, that's not a congruent relationship?
Vertical.
That one is congruent.
Oh, wait. Supplementary.
Supplementary. Yeah, it's supplementary.
Same
So
thing.
if you're looking at a set of angles like this, and you know that they're not the same size, that means they have to be supplementary. And the reason for that is because Maddox just said that this angle 1 is 63 degrees. And then because angle 1 and angle 2 sit on the same line, they're going to add up to 180 degrees. So what you're going to notice is that there's only 2 different angle relationships here. Every angle is either 63 degrees or 117 degrees. So I know this one's 63 degrees because they're vertical. I know this is 63 degrees because it's vertical to this one. It's also alternate interior to this one. I know that 117 degrees has to be the angle of this measure, or this angle measure, because it's vertical to that one. And then I know these both have to be 117 degrees because this one's corresponding to that one, and this one's alternate interior to that one. It's also corresponding to that one, and it's also, this one's alternate exterior to that one. So all the angle relationships are happening. So when you have 2 lines crossed by 2 parallel lines crossed by a transversal, you're only actually looking at 2 different angle measurements. There's 8 angles. 4 of them are going to be 63 degrees, and 4 of them are going to be 117 degrees. All right. Now it says use the figure to find the measures of the numbered angles. What's its relationship to the given angle? So the 75-degree angle. I'm just going to start calling on some people so we don't have the awkward silence. So Alex, Aaron, you're first up. Alex, what's the measure of angle 1?
75 degrees.
75 degrees. Excellent. And what's its relationship to the given angle here, the 75-degree angle?
It's like, forget the word. It's like across from it. So
Okay,
it's
so
like
yep, go back up in your notes. It's one of those 5. It's one of these 5, right?
mhm. It's
2 angles that are opposite from each other.
vertical.
Vertical, you got it. Nice job. Yeah, this is vertical. Yep, those 2 angles are vertical. If they sit on the same line, like the same line, and they don't even use the other one, then yeah, we know vertical because we did a whole assignment on vertical angles yesterday, or at least we should know vertical if we did the assignment. Okay, the next one is angle 2. Angle 2. And so Shane, can you tell me what angle 2 is going to be?
105 degrees.
That's correct. And Shane, what's its relationship to the given angle? Shane, is it equal to 75?
No.
No. So let me narrow this down for you. We've only got one angle relationship that's not equal. They're not congruent. Which one is it?
Is it supplementary?
Yeah, supplementary. So Shane, ask yourself, how did you know it was 105 degrees? You subtracted from 180, didn't you?
Mm-hmm.
Yeah, so that tells you that's what supplementary means. And I'm going to abbreviate that. And by the way, you can abbreviate these. I guess you could put vert if you wanted to for vertical angles. All right, sup for supplementary. What about angle 3? Angle 3 is the next one. Angle 3. Dawson, what's angle 3 gonna be?
105.
Good. And for what reason?
It is supplementary to
Yep.
75.
That's exactly right. It's the same, basically the same response that Shane just gave. So anytime you're putting the opposite angle measure down, so like the 105, it's always going to be supplementary to this, to the 75-degree angle. So every time we put 105 degrees down, that's going to be our reason why. What about angle 4? Lizzie Conyers, can you tell me about angle 4? What would it be?
105.
It's not 105.
75.
It's 75. Can you tell me why it's 75 other than just saying it's congruent? What makes it congruent to the given angle? Is it vertical, corresponding, alternate interior, or alternate exterior?
Vertical.
They're not vertical because vertical ones are on opposite sides of an intersection. So the only one that's vertical to the 75-degree angle is the one that Alex gave us for angle 1. So not vertical.
Alternate exterior.
Not alternate exterior because they're inside.
Alternate interior.
There it is, alternate interior. Yep, so I'm gonna put alt and then int. That's my abbreviation for alternate interior. And so they are on opposite sides of the transversal. This is my transversal T. So they're on opposite sides. So there's your alternate part. And then they are inside the parallel lines, right? So inside the railroad tracks. That's going to be alternate interior. Good. Okay. By the way, I know these are new vocab words. So I'm not going to like, get mad if you don't have the answer right away. That's the whole point of, I'm glad you guys are here because the people that aren't here are going to be a little lost unless they watch this video. What about angle 5? Let's do Oliver for angle 5. Oliver, what's angle 5 going to measure?
105 degrees.
And the reason?
Supplementary.
Supplementary. Yep. Yep. If we know angle 4 is 75 degrees, because Lizzie just told us that, then angle 5 is, which is next to it and shares that same line, is also going to add up to 180. So it's going to be supplementary. So all the angles that are corresponding with the 75-degree angle are going to have a reason why, or not, sorry. All the angles that are congruent with the 75-degree angle are going to have a reason why. It's either vertical, corresponding, alternate interior, alternate exterior. All the angles that are different are all just supplementary. And so if you look at this, it's kind of hard to tell, but you can, if you look close enough, you can tell there's a series, there's 4 acute angles and there's 4 obtuse angles. The acute ones are all going to be 75. The obtuse ones are all going to be 105. Christian, what's up?
I just had the answer for the next one.
Go ahead. Angle 6, Christian.
75 degrees and corresponding.
That's exactly right. Nice job. Yep, and I'm just going to abbreviate everything, and you guys can do the same thing. Yep, corresponding means the same angle on the same location on the other line. And so corresponding, top right, they're both, they're the same angle, and they're going to, of course, they're going to be the same size then. Okay, and then our last one here is angle 7. And Chloe Sheasley, can you tell me about angle 7?
It's 105 degrees and supplementary.
That's exactly right. 105 degrees and supplementary. Awesome. Okay. Let's time out for a second. Time out. I want to see how well we understand this. Okay, I'm going to call on some people here. I'm going to highlight some angles, and I just want you to tell me what the relationship is. I have not heard from Connor Kendall yet. Connor, 4 and 6. What kind of relationship do 4 and 6 have?
Supplementary.
Not supplementary. They are the same size, so they're congruent. Can you tell me why they're congruent? they're on different sides of the transversal. There's my hint. They're on alternate sides of the transversal.
Alternate interior.
That's right. Yes, alternate interior. Okay. Okay. What about Owen Miller? Owen, can you tell me about angle 1 and angle 3? What's their relationship? Why are they congruent?
They're vertical.
Vertical. Good. Okay. Emerson. Emerson, what about angle 7 and angle 3?
Is it alternate exterior?
They're not on different sides of the transversal, so it's not alternate anything.
Okay.
Yeah, so this is my transversal T. This is the transversal line. They're on the same side. They're actually in the same location too. What do we call angles that are in the same location?
Adjacent.
That means they're touching.
Corresponding.
You got it. Yep, they're corresponding. Good. What about angle 7 and angle 1? Angle 7 and angle 1. What do you think about that? Garrett, what would you say?
Alternate exterior.
Alternate exterior. Okay. That's the new part of today's lesson. It's vocab. You just have to study it. Okay. So let's do, we got a couple questions and then we got a homework question, and I don't want to take up too much of your time. So let's just power through this. A store owner uses pieces of tape to paint on a window. The letters are slanted at 80 degrees. What's the measure of angle 1? So here's my 80-degree angle. Here's my parallel lines. Whoops, that was a bad line. There we go. Parallel lines crossed by a transversal. Does it look like the 80-degree angle is the same size as the 1-degree angle? No, 80 degrees is acute, and this 1 degree is obtuse. So I can rule out vertical, corresponding, alternate interior, and alternate exterior. So if they're not one of those 4, what angle relationship am I looking at here then? Xander?
Supplementary.
Supplementary. So Xander, if I know they add up to 180, what's angle 1 have to be?
100.
100 what? 100 degrees. Yeah. By the way, this little symbol right there is an angle symbol. It tells we're looking at angle 1. And then all of our angle measurements have to have degrees. Make sure we're putting degrees on all of our angle measurements, so there's not just a number. So that's right. Good job. Okay, next question. See, these are pretty easy once you know why the answer is the way it is. The photo shows a portion of an airport. Describe the relationship between each pair of angles. We've got angle 3 and angle 6. I'm going to highlight them here for you. Angle 3 and angle 6. Deegan Schoaf, can you tell me if those angles are supplementary, vertical, corresponding, alternate interior, or alternate exterior?
Alternate exterior.
That's correct. Nice job. They are alternate exterior. And if you're struggling with that, remember, this is your transversal. So they're on different sides of the transversal. So there's your alternate part. And then they are outside the railroad tracks, or in this case, the airport runways. So they're outside the parallel lines, which makes them exterior. Okay, let's do the other one here. Angle 2 and angle 7. Angle 2 and angle 7. Sky, can you tell me what the relationship is there?
Alternate interior.
Nice job. These are alternate interior. Still on opposite sides of the transversal, but now they're inside the parallel lines. Alternate interior. Good job. Okay, so here's a warning. When you guys take this upcoming quiz next week, and I ask you, hey, what's the measure of angle 7 and why is it this? Like, what's its relationship? Don't put that it's congruent. I know that it's congruent. There are 4 angle relationships up here that are congruent. I want to know why it's congruent. So don't ever put congruent as the reason why it's the same size, because that's literally what the word congruent means, the same size. Tell me why, by putting vertical, corresponding, alternate interior, alternate exterior, or if it's not congruent and it just adds to 180, there's your supplementary. Okay, let's look at one homework question and then we are done. This is number 30. The figure shows the angles used to make a double bank shot in an air hockey game. Find the value of X. Okay, so you could probably do this one without, let's do this. You could do this one without knowing much about the transversals and parallel lines and all that such, but it certainly helps. And so to find the value of X, I know that X is going to, well, here's angle X. Which of these 3 angles over here is X going to correspond to? Which one, Maddox?
64 degrees.
64. Okay, I apologize. I said correspond. I meant be congruent with. I meant be congruent to. You are right. It's 64 degrees. Can someone tell me what? It's not corresponding. I misspoke. I'm sorry. I meant to say congruent to. Can someone tell me what angle relationship you see? Like, why is the angle X? Why is it congruent to 64? This is for anybody. Just shout it out when you know. Like, what's the angle relationship?
Alternate interior.
Alternate interior. Good job. Yeah, so that might help. If I were to cover this up and cover that up, and then you twist your iPad a little bit, that's gonna be their opposite sides of the transversal, and then they're also inside the parallel lines. So angle X is going to be 64 degrees. Now, if it doesn't say what's the measure of angle X, then you can just put 64. But if they specifically ask you for the angle measurement, that's where we need an angle. That's where we need a degree symbol. Okay, so then to find angle M, because I know that these sit on a straight line, I would say that M plus M, or 2M, plus 64 has to add up to 180. And I could just solve this equation to find out what M is, right? But I don't think we need to know what M is. Nope, so angle X is going to be 64 degrees because it's alternate interior to the 64-degree angle, which means it's congruent. It says if you hit the red puck from the same location in the diagram, can you still get the puck in the goal when X is increased a little or by a lot? Okay, so let's think about this. I'm going to erase. Let's say the angle X is increased a little bit. Would you guys agree that's a little bit bigger? Yeah. Can you still make it into the goal? I think you could, right? If you increase X a little bit. So look where X is hitting. X is hitting right here, right? I mean, you could still increase it a little bit, maybe not as much as I did, and you could still get it to hit the goal right there. So we can increase X a little bit. X does not have to be 64 degrees for us to make this double bank shot. But it says, can you increase X by a lot? If I increase X by a lot, the answer is no, it is not going to. So let's see what the options are. By studying the diagram, you can see the X cannot be increased and still have a puck. Okay, that's not true. It does not have to be exact. So that's not true. It can still be a little bit bigger. By studying the diagram, you can see X can increase a little and still have the puck go in with a double bank shot. That would be correct. By studying the diagram, you see that X can increase by a lot and still have the puck to go in with a single bank shot. Ooh, I didn't even see that, a single bank shot. Could I increase X by a lot and have a single bank shot? The answer is yes. Yeah, if we're not trying to make a double bank shot, we could always make a single bank shot. And so because it said single bank shot, you could also select that one. But there's no way that you can increase an X by a lot and still do a double bank shot.